Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. Today we're going to finish up Unit 6 and talk about how to find the average value of a function. So, to begin, take a look at these first two problems here. One constant function, one linear function, and see if you could find the average value of the function over the intervals 0 to 10, or the interval 0 to 10 for both of those functions. So pause the video, see what you can do, and then come back and join me for a discussion. All right, so for the function on the left, we see that is a constant function, and a constant function just means that it has the same y value for every x value. So if the y value never changes, well then the average y value is just going to be the y values, right? Because they're all the same. And an equation for this function, right, f of x is equal to 8, regardless of what the x value is. So the average value, we would say, is equal to 8 as well. For the one on the right, it's a little different. It's a linear function. It's not constant. So the y values do change as the x values change. However, because it is linear, we could just use what we know about averages. Take the initial y value, take the ending y value. So 8 plus 4, and divide by 2. Right, so it's going to give us 12 divided by 2, which is going to give us 6. And that makes sense, right? Because this is linear, then the middle of those two values, right? If I mark off 6 on the y-axis, right, you can see from 0 to 10, half of those y values are above 6, half of those are below 6, and it's linear, so it's increasing and decreasing by the same amount, depending on which way you want to look at it. But the average value here, or the average y value, would be 6. Let's take a look at a little bit more of a complicated example. So here we have a nonlinear function, which means it probably doesn't look like it's that easy to know exactly what the average y. When I say average value, I mean, or we as a mathematical community mean the average y value. So again, average value just means the average y value. In this case, they're asking you for the average value over the interval 0 to 5. Doesn't seem like it's very easy to figure out, maybe off the top of your head, but take a guess. So write down your guess, and then we'll compare it to what the actual answer is once we know how to find it. Okay, so maybe you think the average value is somewhere around 90. So I'm just going to make that our guess, and we'll compare that at the end and see if we were close or not. The next few questions are going to take us down a path of figuring out the process for finding the average value. So we're first going to assume that this is a velocity function, where x represents the time in seconds and f represents the distance in meters. So the first thing we're going to do is write an expression for the total displacement of the particle over the interval 0 to 5. So think about, do we need any absolute value signs for displacement, or do we only need them for net and total distance? See if you can write that expression. It's going to be an integral expression. I'm actually going to scroll up here just a little, maybe so we can see the rest of these questions. All right, so I just moved all the questions up here so I didn't have to keep scrolling down and we can't see the graph, etc. Although now we can see the function. Let me fix that for us. All right, now we have everything we need. So an expression for the total displacement, all we would do, so displacement, that is just the area under the curve of a velocity function over the given interval. So displacement is going to be the integral from 0 to 5 of f of x, so negative x cubed minus x squared plus 21x plus 45 And then don't forget your dx at the end. So that would represent the total displacement. Now you need to evaluate that interval. You are allowed to use a calculator. You don't need to do that by hand. So quickly punch that in, round to 3 decimal places. Actually, we'll round to 4 because we're not quite done with this problem yet. And we end up getting approximately 289.583. We could think, what is this? What are the units here if we are taking the integral of a velocity function? Well, again, pause the video, think about what those units should be. Well, whenever we evaluate a definite integral of a function, the units are going to be from what the original function would have been. So if we're evaluating velocity, the units are going to be what the units would have been for the position function. In this case, meters. So if our function is displaced this amount, right, 289.5833 meters over the interval 0 to 5, well, think about how we could use that to figure out the average velocity. Right, so over the first 5 seconds, that's the average, not the average displacement. That is the displacement. So how could we figure out the average velocity, which would be the average value of f of x? Well, you could just divide that displacement by the total amount of time, right? We've been traveling for, the particle's been traveling for 5 seconds. So we can divide this value right here by 5, 289.5833, divide by 5. Remember, this is in meters. Just want to keep our units here so we understand what our units will be for our average value. This denominator was in seconds. So if we perform that arithmetic, this time we'll round to 3 decimal places, we get 57.917 meters per second. And that makes sense. We should get meters per second because we were trying to find the average value of the velocity function, and those would be the units for the velocity function. And again, we can think about it. If on average they were traveling at a speed of 57, they were traveling at a speed, which is the velocity, of 57.917 meters per second, well, then they would have traveled, or their displacement would be 289.5833 meters after 5 seconds. See if you could write an expression or be able to explain how to find the average velocity on the interval 3 to 5. So go ahead, work through number 7 on your own, and then we'll come back and see if you were correct. Okay, so there's a couple ways you could write this, and I'll show you. I'll write down multiple ways just in case you did it differently. So for number 7, the first thing we need to do would be to find the displacement of the particle, right, over that given interval. So we would have the interval, or the integral rather, from 3 to 5. And instead of writing out the function, I'm just going to put f of x dx. Now, that's by itself is not going to give us the average value of f of x, though. Right? At the end, we had to divide by the total amount of time on that interval. Right? In this case, the total amount of time is just 2. Because we were traveling on the interval 3 to 5, so 3 seconds to 5 seconds. Now, again, a couple other ways we could write this. We could say the integral with limits 3 to 5 of f of x dx. And instead of dividing by 2, we could just multiply by 1/2. Or the final way of writing it, same integral, right? That's not changing. It's just the way we write the 1/2. And this this last one will really show you how we're getting that fraction, right? It would be 1 over 5 minus 3. So you're essentially subtracting your limits of integration, right? Your ending x value minus your initial x value. But either one of these, right? Whether you wrote out the pink, the green, or the orange, right? All of these would give you the average, in this case, average velocity. But this is what you can use to find the average value of any function. I just wanted to put it in terms of position and velocity because we're familiar with those, so it may have made sense, how we were going back and forth. But this is how you would find the average value of any function, regardless of whether it's a velocity function. So let's go ahead and let's put this all together, a nice little box. The average value of a function. Now there is one criteria for us to be able to find the average value of a function over the given interval, right? And that is given f of x is continuous on the closed interval a to b. So you've got to check for continuity. Otherwise, this formula is not gonna work. But given f of x is continuous on a to b, then average value of f of x on a to b is given by one over b minus a times the integral with limits of integration a to b of f of x dx. So here's your formula for average value given that that function is continuous on the interval, on the closed interval. Okay, to close out this video, we're not going to go through these easier examples to practice, but we are going to look at the very last question on here. It's a practice AP FRQ. Let me just put this by itself. Okay, so a question from the 2003 AP AB exam. So you're actually given a piecewise function here, and you're asked to find the average value of f of x on the closed interval 0 to 5. So you're going to have to use that formula from up above. Make sure you check initial conditions, and then figure out how you could evaluate here. And just a heads up, this would be a non-calculator question. If you need help evaluating the integral for average value, you can go ahead and use a calculator because we haven't talked about all the different integral techniques, but I think you can probably take the antiderivative by hand. But again, for this specific question, because we haven't done all of our integral rules, you can use a calculator for the integral only. Okay, so the first thing we need to check, right, is that the function is continuous on the interval 0 to 5. And, well, usually that may be trivial, but here it's a piecewise function, so we've got to go through our three-part definition of continuity where the function is broken up, namely x is equal to 3. So they're testing multiple things in this question, right? They're testing your understanding of continuity, and they're testing your understanding of absolute or average value. I hope I haven't said absolute value when I was supposed to have said average value in this video, but if I did, let me know. To check for continuity, right, 3 parts is we need to know that f of 3 exists. So f of 3 is equal to the square root of 3 plus 1, which is equal to 2. So f of 3 exists. Again, I'm using this part of the piecewise function because that is where x is equal to 3. I then need to check that the limits of I need to check that the one-sided limits are equal to one another, so I can prove that the limit as x approaches 3 of f of x exists. So I'm going to do the limit as x approaches 3 from the negative side of f of x is equal to the limit as x approaches 3 from the positive side of f of x. Make sure you use the right functions there. Use different color. So I'm going to get the limit as x approaches 3 from the negative side, and I'm using the square root of x plus 1 is equal to the limit as x approaches 3 from the positive side, and for this function I'm using 5 minus x. Simple substitution here. So I get the square root of 3 plus 1 is equal to 5 minus 3, and that gives me, that does indeed give me 2 is equal to 2. We're not done with continuity here. This just lets us make another conclusion. So we can say, thus, limit as x approaches 3 of f of x is equal to 2. Then we have one more conclusion here, right? This was all the second part of continuity. Our third part, we can say, since f of 3 is equal to the limit as x approaches 3 of f of x, f of x is continuous at x equals 3. So that would be a full explanation for just the criteria for us to find average value, right? So all of this would be required just to prove that the function is continuous at x equals 3. Once you have all this, you can then move on to using the formula for average value. So I'm going to get rid of all of this. Again, you can pause the video and make sure you have it all down. Now I'm just going to start working out average value. So average value, we have 1 over we have 1 over b minus a, which in this case would be 5 minus 0, times the integral from 0 to 5 of f of x dx. Now we've got to break up our integral portion, right, because it's a piecewise function. So this becomes 1 over 5 times the integral from 0 to 3 of the square root of x plus 1 dx plus, and again, we're just using properties of integrals here, the integral from 3 to 5 of the function 5 minus x dx, close bracket. So this would be the integral that we have to evaluate. Again, this would be something you would need to do by hand. Because we haven't talked about how to do use substitution yet, which will be in our next unit, which is what you would need to do to be able to go backwards essentially from that function right there and take the antiderivative. So again, calculator is allowed today. Just know that eventually we should be able to figure this out by hand. So pause the video, take some time to punch this into your calculator and see what you get. And depending on, if you do this by hand, you'll get an exact answer of 4/3. Right, so if you attempted to work it out by hand, we should get 4/3. If you use the calculator, you'll get an answer of approximately 1.333. Again, today we're focused mostly on the setup here. And again, once we know how to do use substitution, we'll be able to do this completely by hand. But again, this was a bit of an easier, I'm just talking about how to take this antiderivative right here. Intuitively, you may have been able to figure it out on your own anyway. Okay, we are going to wrap it up for this lesson here. As always, enjoy the rest of your day, and we will look forward to seeing you next time for a brand new unit.